my name is Stephen, and in this short module we're going to be covering how we can use mechanical polishing to make sure that our working electrode has a clean and reproducible surface before every experiment. In analytical electrochemistry, we are often most interested in the reactions that are occurring at the working electrode. For this reason, it's important that we clean our working electrode in between experiments so that the response of the electrode in one experiment is not influenced by the state of the electrode from a previous experiment.
This can be achieved with mechanical polishing, in which the surface of the working electrode is moved across the surface of an abrasive material, such as silicon carbide or alumina. When a contaminant from a previous experiment is attached to the electrode surface, mechanical polishing removes this contaminant through abrasion. With continued polishing, the surface layer of the working electrode material is also removed, revealing a fresh layer of the electrode material for the next experiment. Depending on the state of the electrode, different grades of the abrasive material may be needed. Routine polishing can be done using higher grades comprised of smaller particle sizes. Recessed electrodes or stubborn adsorbents may first need rough polishing on lower grades before later finishing on higher grades.
Therefore, a quick polish on 0.3 micrometer alumina should be sufficient to clean this electrode. We can take a felt polishing pad and we can add some of this alumina, and then we can add some deionized water to make a polishing slurry which we can use to polish the electrode. Or we can use a pre-made slurry instead.
We will position our electrode parallel to the felt surface and move it around in a smooth figure of 8 motion, always making sure the surface remains flat on the felt. This way, we ensure the direction of polishing is continuously altered and the electrode is not polished excessively in one direction, which would produce a beveled electrode surface. We go from lower grades to higher grades because of the effect polishing has on the electrode surface. The abrasive material is harder than the electrode material and leaves a scratch in the electrode surface roughly equal to its particle size. Larger particles therefore make the electrode rougher and lead to a greater heterogeneity in the electrode surface. Smaller particles reduce the roughness, making the surface area of the electrode closer in size to its geometric area. When we are done, we can wash our electrode with water, remove any excess alumina by buffing the electrode on a wet cloth, and dry with argon. The polishing progress can be assessed using optical microscopy, with the absence of visible scratches suggesting the completion of polishing.
So thank you for watching this video on mechanical polishing. Whilst you're here, why don't you check out some of the other videos we have in this course, such as the one about electrochemical polishing, and I'll see you in the next video.